Section 5.1 Fundamental Trigonometric Identities. Let's recall what an equation is. An equation is a statement that equates two mathematical expressions. For instance, x plus 3 equals 7 is an equation. X plus 1 squared equals x squared plus 2x plus 1 is another equation. A cubed plus b cubed is equal to the product between a plus b and a squared minus ab plus b squared. This is also an equation. And this equation that we've seen many times in this course, sine squared x plus cosine squared x is equal to 1. So all these four are equations. An identity is, to begin with, an equation, but it's an equation that's true for all the values of the variable or the variables. So an identity is more than being an equation. It's an equation that works for all the values of its variable or the variables. For instance, this last equation that you see here, it's an identity because this works no matter what x is. Correct? No matter what you plug in x here and here, this side is always equal to 1. The third equation, this is also true for all a and b. No matter what you choose a and b, this side is going to always be equal to this side. And the second as well. So the last three equations are identities. Now for the first one, this is not an identity because if you give me an x that's different than 4, then the left side and the right side do not match. So all of these four are equations, but only the last three of these are identities, according to this definition, right? All right. A trigonometric identity, it's an identity, according to the definition we just had, involving trig functions. Okay, so you attach this adjective, it becomes trigonometric identity. This phrase means an identity that's involving trig functions. Okay. All right. Let's revisit basic trigonometric identities that we studied so far in this course. We have these reciprocal identities. These ones. Cosec is the reciprocal of sine. Sec is the reciprocal of cosine. Cotangent is the reciprocal of tangent. Tangent is sine over cosine. And cotangent is cosine over sine, right? Another identities that we learned in this course are referred to as the Pythagorean identities. This one that we just talked about above, tangent squared plus 1 is equal to sec squared, and 1 plus cosine squared is equal to cosine squared, right? Cosec squared, correct? So, by the way, in the proof we realized that all three are equivalent, so, right? If you show one, you can show all the other two. We also developed even-odd identities. We realized that sine is an odd function, so sine of negative x is minus sine x. Cosine is an even function, so cosine of negative x is cosine of x. And tangent is an odd function, so tangent of negative x is equal to negative tangent x. And everything so far mentioned is for real numbers, right? No matter what x is, as long as it's a real number, it works, provided both sides work, correct? For example, here, these two are the same as long as cosine of x is not 0, for instance, correct? But as long as both of the sides are meaningful, then they are equal. And the last set of identities, which we refer to as the cofunction identities, sine of pi over 2 minus x is cosine of x. Cosine of pi over 2 minus x is sine of x. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions as well. And sec and cosec, right? So all these properties that we see, all of these properties that we developed in this course hold for all real numbers x as long as both sides of the equation are meaningful. All right, so let's start by doing a few examples in this section. Let's go to the book. Okay, so I'm on page 575 in the textbook, 602 in the PDF. And let's go to objective 1, and how about we do number 10. Okay, so what's the question here? The question is, find the least common denominator, then rewrite each expression with the new denominator. Okay, so number 10 has two parts, A and B. All right, so this is on page, as we said, 575, and okay, let's do number 10. Part A, we had 1 over A and A over 1 minus A. So 1 over A and A divided by 1 minus A, right? Okay, so what do we need to do? We need to find the least common denominator and then rewrite each expression with this new denominator. Well, between A and 1 minus A, what's the least common denominator? It's the product between the two, right? For example, between 2 and 3, if this guy is, let's say, 3 and this guy is 2, say, okay? So between those guys, the 2 and the 3, the denominator is 2 times 3, the least common denominator. So between A and 1 minus A, the least common denominator is A times 1 minus A. Okay, so I'm gonna rewrite each one of them as something over A times 1 minus A. Right, I'm gonna rewrite each one of them as something times something over A divided A times A 1 minus A, right? The product of the denominators. Well, something over A times 1 minus A should be 1 over A. In other words, what did I multiply A with to get A times 1 minus A? Well, we multiply by 1 minus A downstairs. So we have to do it also upstairs to preserve the value of the quotient, right? So we're going to also do it upstairs to preserve the value of the quotient. Okay, so here I'm not teaching anything new to you. You've known this from other courses, but we're going to use it in part B. They're kind of like setting the stage for part B. Okay, so one more time. We multiplied above and numerator and denominator by 1 minus A. This is a 1, right? So the value of this quotient is still 1 over A, but the look is different. It looks different, but the value remains the same. Similarly here, we transitioned from 1 minus A to A times 1 minus A. So what did we do here? We multiplied downstairs by 1 minus A. We gotta also do it upstairs. Sorry, we multiplied downstairs by A. We gotta also do it upstairs to preserve the value of that quotient. So upstairs you get the existing A times the new A. So that's gonna be A squared, right? You can recheck, you can simplify by A and get back this to convince yourself that the value is the same. Okay, so we rewrote each one of them as something over this least common denominator between A and 1 minus A. Correct? And this was the question. Part B, we have 1 over cosine x and cosine x divided by 1 minus cosine x. So for part B, we have 1 over cosine x, and we also have cosine x divided by 1 minus cosine x, correct? Well, the format is the same. If you look at cosine x, I'm going to try to deduce from part A. If you look at cosine x as a, this becomes 1 over a, and this becomes a divided by 1 minus a, right? One more time. The structure of these quotients are similar to the previous part. If you realize that, or if you come up with this dictionary, a is cosine x, or cosine x is the a in part A, right? If you see it this way, it's just a matter of just rewriting the whole thing here with cosine to be the a. Make sense? Okay. If you don't want to rely on part A, if you want to pretend that part A didn't exist altogether, let's start it from scratch. So 1 over cosine x and something over cosine x and something over 1 minus cosine x. So the common denominator between cosine and 1 minus cosine is the product between the two. So we get cosine x times 1 minus cosine x. And I hope you realize that we are doing exactly the same as before, okay? But by renaming a to be cosine of x. All right, and here as well, I'm gonna be able to rewrite this as cosine x times 1 minus cosine x. The question is, who sits upstairs here and here, right? Well, how did we go from cosine x to cosine x times 1 minus cosine x? We multiplied downstairs by 1 minus cosine. If you want to multiply downstairs by 1 minus cosine of x to preserve the value of the quotient, you gotta also do it upstairs. Let's also multiply upstairs by 1 minus cosine. And get or answer the question. We rewrote 1 over cosine as a new quotient where the denominator is the least common multiple between cosine and 1 minus cosine, so it's the product, while preserving the value, right? While preserving the value, and realize that we did exactly what we did in the previous part. Okay. All right, similarly here, what did we do to go from 1 minus cosine x to 1 minus cosine x times cosine x? We multiplied downstairs by cosine of x. Well, to preserve the value, I have equality. To preserve the value of this quotient, I gotta also multiply upstairs by cosine of x. And if you multiply upstairs by cosine of x, I already have cosine of x, so they're gonna pile up and they're gonna be cosine of x squared as in the previous one, right? So I'm gonna get cosine of x squared. And cosine of x squared notationally is written as cosine squared of x, correct? So this is the same thing as saying cosine of x squared. So one more time, let me remind you, this is a notation for the square of cosine of x, right? Okay. All right, let's move on. So we did 10. How about we do one of these, 11 or 12? How about doing 12? So the question is to multiply, and we want to multiply in part A minus b times itself, and part B, we're going to multiply sine x minus tan x by itself. So this is number 12. Oops, let me choose the purple again. So as we said, in part A, we're going to multiply, we're going to find the square of a minus b. Correct? Well, a minus b squared is a minus b times a minus b. correct? And if you FOIL it out, you get a squared. So a times a is a squared. A times b is negative ab. Negative b times a is negative ba. And negative b times negative b is plus b squared. Okay, so what do we get? Well, a times b is the same as b times a because multiplication is commutative. So negative something negative itself is minus twice the thing, right? So you get a squared minus 2ab plus b2, which is property which most likely you've seen many times before. So the square of the difference is equal to the sum of the squares, a squared plus b squared, minus twice the product. Okay. For part B, they wanted us to find the square of sine x minus tangent of x. Correct? This is part B. And either you reinvent the wheel or you can rely on part A by just assigning this dictionary. A is sine x and B is tangent of x, right? So I'm gonna use actually property A that we developed in A, that the square of a difference is this much. I'm gonna use it here with the dictionary that sine x is A and tangent of x is B. Okay, so I'm gonna use part A with the following choices. I'm gonna assign to A the role of sine of x, and I'm gonna assign to B in part A the role tangent of x. Correct? And as such, I'm gonna obtain what? The square of A. And who's my A? That's sine of x. So I'm gonna get the square of sine of x. Oops. One more time, the square of sine of x. And the square of sine of x is written as sine squared of x. Again, it's very similar to the meaning of cosine squared. It's the square of cosine. So the square of sine, if you remember, is written as sine squared minus 2 times a, who's my a here? Sine of x, times b, right? Times the b. Remember, I'm applying part A with these choices of the variable or the parameters a and b, right? So 2 times a, which is sine x, times b, which is tangent of x. So I'm still missing here tangent of x. Plus the square of b. The square of b, which is the square of tan x. So we get this. Correct? Okay, so this is number 12. Okay, let's move on. So we finished this. Let's do a couple of problems from 13 to 20. So what's the question? Factor each expression. How about number 16? Okay, you have the difference of cubes, and you have over here, and you have an application of it, right? Because this is still the difference of cubes. Okay, so part number 16, we're gonna factor a cubed minus b cubed. Well, this is a property that most likely you've seen, and I think I've written it here. Oh, I wrote it for plus. Well, the minus is very similar. Just relabel b to be negative b, so you get. Let me write it here anyway. So you get a cubed minus b cubed to be a minus b times a squared plus ab plus b squared. Okay. So this is an identity. I mean, to trust me on this, just foil the side, right? If you foil the side, the sum is gonna collapse, and the only leftover is gonna be just a cubed minus b cubed. So try it out, please. So part A, I'm gonna just, okay, so this is a minus b times a squared plus ab plus b squared, right? This is what we had on above. For part B, they gave us cosine cube x minus cotangent cube x, right? Okay, so the structure is the same. This is still the difference of two cubes. The structure is the same, and to convince you, let me give you who's playing or the role of A and the role of B in this expression. Well, it's not very hard to see that A is actually cosine x and B is cotangent of x. So if you with this dictionary or with this assignment of A and B, you can see that this structure is exactly the structure. So what we're gonna do, we're gonna factor, right? So we've already done the work above, so we're gonna use part A with the following assignments. A is cosine of x and B is cotangent of x, right? Okay, and as such we obtain what? The difference between A and B, so you get cosine x minus cotangent of x times a squared, and a squared is cosine squared, plus ab, right, the middle term, and ab is cosine x times cotangent of x, plus b squared, and b squared is cotangent squared, correct? And if you multiply these out, you get exactly the side. Okay. All right. So we finished 16. How about 18? How about 18? So you have a squared minus 2ab plus b2, and this guy, sine squared minus 2 sine x, tangent x plus tangent squared. Okay. So part number 18. So part A, you have a squared minus 2ab plus b2. Okay. Again, the question is to factor. Didn't we just do this above? Yeah, it's right there, right? So it's the way back. We expanded at the time, we multiplied a minus b squared, you see it, part A, number 12, and we got this. So this and this are the same. Now they want us to factor it. They want us to factor this guy, and factoring this guy is exactly writing it this way, right? So factoring again means write it as a product. This is a sum of three summands, 1, 2, 3, right? It's a sum of three things. You want to write it as a product. You want to factor it. And since we've done it, I'm gonna just, sorry about that. I'm gonna just write it here. This is a minus b squared. Okay. For part B, they gave us sine squared of x minus 2 sine x tangent x plus tangent squared x. Okay. They want us to factor this. Well, it looks complicated, And what do you think? I hope you stop this and take a few seconds or a few minutes to think about factoring this guy. But I hope you get to the following conclusion. The structure of this is exactly the structure of the left side of part A. Correct? This looks like something squared, and this looks like something squared with the plus in front, with the plus here in front. This minus is reminiscent to this minus 2 times the product of A and B. So A is sine apparently, and B is tangent. You get sine times tangent as A times B. Correct? So structure-wise, you can regard them the same way. But they changed the name of A to be sine, and that they changed the name of B to be tangent. Okay. So what's the deal here? The deal is to, I don't know why this is dilating all of a sudden. Okay. So what's the deal here? The deal is I'm gonna use part A above with the choices of A being, as we said, sine of x, and B is equal to tangent of x, correct? Agree with me? If you assign the role of A to be sine and the role of B to be tangent of x, this side, this guy, this whole expression is exactly the left-hand side of this identity in part A. All right, and we've done the work. This is A minus B squared, and A is sine that we chose, and the B is tangent. So that's going to be the square. That's going to be the square of the difference between A and B. Of the difference between A and B. And A is sine and B is tangent. So sine x and tangent x, right? Agree? Okay. So this is number 18. Okay, let's go to the next cluster of problems. 21 to 36. Simplify the expression. Write the final form with no fractions. So they want the answer, the simplified version of the expression without any fractions. They don't want fractions, okay? All right. Let's do 22. 22 is cosine x times tangent x times cosec of x. So 22. We have cosine of x times tangent of x times cosecant of x. And what's the question? The question is to simplify and write without fractions. Okay. Well, what do you know about tangent? What we have tangent, we have cosec, right? Again, the best way to do these problems is to try them out, obviously, by yourself. And I mean, your brain should dry over it. You should keep trying and trying and trying until you run out of options, and then you look at the solution, and then you know exactly what piece you were missing, okay? And by the way, the solution is not, the answer is unique, but to get there is not, there's no one way to get there. So I hope you, you don't just do what I suggest to do. You have to discover, you have to come up with your own, or express yourself in the solution, please. All right, so I came to this part to remind you that tangent is sine over cosine of the same argument, the same x. And cosec, we need cosec, is 1 over sine, right? Of the same argument. Okay. Cosine of x, I'm going to keep it, times tangent, as we said above, is sine x divided by cosine x. Tangent of x is this much. And times cosecant of x. Oh, sorry. I meant to rewrite cosecant as 1 over sine, right? It's one of the identities, again, just revisited shortly, just a few seconds before. All right, and look at this now. This looks cosine x sine x divided by cosine x sine x, right? If you multiply all three quotients, you can see that this is simply cosine x times sine x above divided by cosine x times sine x downstairs. So something divided by itself is 1, right? Assuming that the entity is not 0, obviously. So this is 1. So all this product is simply 1, no matter what x is, as long as this is making sense, obviously. If it makes sense, if this product makes sense, it's a 1. Okay, moving on. So we did 22. I'm gonna try to do as many evens as I can, because you have the answer for the odd at the back of the book. How about 26? Cosecant squared times tangent squared times secant of x. Let's try to simplify this expression. So 26, we have cosecant squared of x times tangent squared of x times secant of x. Okay. All right. Cosecant, we just recalled it, it's 1 over sine. Tangent is sine over cosine, and secant, if you revisit the identities mentioned at the beginning of this section, secant is 1 over cosine. Correct? So I'm gonna see what I get. Okay. Oops. I guess I'm pressing this button all the time. All right. So this is equal to cosecant is, as we said, 1 over sine. And since this is the square of secant, so it's going to be the square of this, right? And the square of 1 is 1, and the square of sine x is the sine squared x. Times tangent is sine over cosine. So tangent is sine over cosine. And I have tangent squared, so that's going to be the square of this quotient. And the square of this quotient is the square of sine divided by the square of cosine times secant, which is 1 over cosine. Correct? Secant is 1 over cosine. All right, and what is this? Well, you can simplify by sine squared. Correct? And what you get above is simply 1, because the leftover here is 1. If you simplify this with this, something divided by itself is 1, right? 1 upstairs divided by cosine cubed downstairs, because cosine squared of x times cosine of x, they pile up, you add the powers, you get cosine cubed. So you get 1 divided by cosine cube of x. And what is 1 over cosine? Remember, this is the same as 1 over cosine of x cubed, right? Check it backwards. The cube of a quotient is the cube of the numerator, which is 1 cube, so 1, and divided by the cube of the denominator, which is this. So they are the same. And what's 1 over cosine again? What's 1 over cosine? It's secant, right? So this is secant cube then. So this is secant cube. And secant cube, secant of x cubed is the same as secant cube of x, right? Why did I write it this way for the last step? Because look, in the question they said they don't need any fractions. So even though the answer is, I mean, I could have left it as 1 over cosine cube, but they said they don't need fractions. So I have to kind of realize what 1 over cosine is. Okay. All right. Let's go back to the book. So we finished 26. 28. I want to simplify tangent of x divided by sine of x times secant squared. So 28. So 28, I would like to simplify tangent of x divided by sine of x times secant squared of x. Okay. All right. Well, tangent is sine over cosine, so let's do so immediately. So tangent is sine of x over cosine of x. And secant is 1 over cosine, right? So secant squared is 1 over cosine squared. So we get sine x times 1 over cosine squared of x. One more time, why this is the case? Because secant of x is 1 over cosine. The square of secant becomes the square of this, which means 1 over cosine squared. Okay. All right, and this is equal to, again, please stop the video, and I mean, wherever you're stuck, just get that hint and then stop it again and keep going. Try to keep going on your own, okay? And you don't have to approach it, you don't have to do the same thing I'm doing, and I hope you don't. But if your way doesn't lead anywhere, then run the way I'm doing it and just see what you were missing in some sense. Okay. All right. Okay, so what do I get then? I get sine of x divided by, okay, let me just write it above. So sine of x divided by cosine of x. And downstairs I have sine of x over cosine squared of x, right? Because you can think about sine of x as sine of x over 1 and multiply these two quotients. So sine of x over 1 times 1 over cosine squared is sine of x times this numerator. You multiply straight across. So sine x times 1, so sine x, divided by 1, this one that sits as a denominator. 1 times cosine squared is cosine squared. So you get this format, right? Okay. And we need obviously to simplify this. You see this fraction bar? That's the division. This is the division. It's at the level of the equality. That's the division that separates this numerator from this denominator. So I'm dividing then. I'm dividing sine x over cosine x, which is the numerator of this quotient. I'm dividing this by sine x over cosine squared, right? This is what this fraction bar means. It means I'm dividing this by this. That's what I wrote, right? And dividing something is the same as multiplying by the reciprocal of this thing. So I can rewrite it as sine of x divided by cosine of x times, again, dividing by something is the same as multiplying by the reciprocal. Now the reciprocal of sine over cosine squared is cosine squared. One more time, I press this. Sorry about this. Cosine squared of x divided by sine of x, right? Just in case you didn't catch it, I remember division and multiplication are intertwined. Dividing by something is the same as multiplying by the reciprocal of the thing. And the reciprocal of this, sine over cosine squared, is cosine squared over sine. Okay, and now I'm multiplying these two quotients. So I get sine x times cosine squared divided by cosine times sine of the same argument. It's x all the time. Okay, so I can simplify if needed. And I do need it because this and this are the same factor. Correct? And here I have cosine squared divided by cosine. So it's like a squared divided by a. It's just a, right? So it's just a. You can divide. Let me change the color. So you can divide the a squared by a and get simply a, correct? So this is simply then cosine of x. Okay, so let's keep going. Let's go to the next page, page 576 this time. And how about 30? So I need to simplify the quotient sine squared x plus 1 divided by cosine squared. The whole quotient is plus 1, right? Let's see this. So this is number 30. I have the quotient sine squared x plus 1 above, upstairs divided by cosine squared of x, and this quotient is plus 1. Okay. Again, please pause the video and just think about it first. What I want to do is I want to create the same denominator between the two. How about cosine squared x as, because here I have over 1, right? So I'm gonna have cosine squared as a common denominator between this expression and this expression. So I'm gonna get sine squared x plus 1 was over cosine squared. I'm gonna write the 1 as something over cosine squared of x, right? And what is the thing? It's just cosine squared of x, right? Because we multiplied downstairs by cosine of x to transition from the 1 downstairs to cosine squared. I gotta also do it upstairs to get that. Okay. Something divided by itself is 1. Okay. So now I can glue them together because they have this common ground, common denominator. I get cosine squared of x, and I get upstairs sine squared of x plus 1. This is coming from the first expression, plus the second numerator, plus the second numerator. Yes? Okay. What do you think next? Do you know anything about cosine squared plus sine squared? Do you know anything about this? What is this? Sine squared of x plus cosine squared of x. Sine squared of x plus cosine squared of x. You see it? It's right there. Sine squared of x plus cosine squared of the same thing, x, is 1. So this green thing is 1, right? So upstairs becomes 1 plus 1, because I already had an existing 1. So it's the green 1 plus the purple 1 divided by cosine squared of x, which is 2 divided by cosine squared. But as you remember from the question, they didn't want us to represent the final answer with quotients, with fractions. So we need to rewrite this as something that without the quotient, without the fraction. But this is the same as 2 times 1 over cosine squared. Agree with me? And 1 over cosine squared is the same as 1 over cosine, and the whole thing is squared. Do you agree with that? 1 over cosine, the whole thing squared, is the same as 1 squared, so 1 divided by cosine squared of x, times 2 comes back to this. So we're writing it this way just to set the stage to a property, one of the reciprocal properties to kick in. 1 over cosine of x is sec, right? This is sec of x. So that's going to be the square of sec of x, which means sec squared, times 2. Then the answer is 2 secant square of x. Correct? All right, next. Oops, sorry. Okay. 34. Should I do 32? Let's do 32. Cosine theta minus sec theta divided by sec theta. This is 32. So 32. I have cosine theta minus sec theta divided by sec theta, right? Okay. Well, again, there are multiple ways to look at this. The way I'm gonna do it, let's say I'm gonna split this quotient, right? A minus B over C is A over C minus B over C, correct? So it's the backward direction. It's like if you wanna find an analog to this thing that I'm about to do, is this equality that you see here. When we glue the two fractions, I'm going backwards this time. I'm gonna split this difference, this quotient. So I'm gonna get cosine theta over sec theta minus sec theta over sec of theta, right? Again, if you wanna recheck the work, this is a common denominator, so I can glue them together and get back to this. Okay, so these are the same. And what's sec theta over theta? What's something divided by itself? Is a 1, right? This is a 1 here. Okay. And what do you know about secant? Secant is 1 over cosine, correct? So we get cosine of theta divided by 1 over cosine of theta. Remember, secant is 1 over cosine minus this guy. How much the value of this guy is? Is it 1? This is how much? Well, cosine theta over 1 over cosine. We've done something similar above. Okay, anyway, so this is cosine theta divided by 1 over cosine theta, right? Correct? This is the numerator, and I'm dividing it by this denominator. So I have this setup. This is what this fraction bar means. And then minus this innocent 1 on the side, right? All right, and dividing by something is the same as multiplying by the reciprocal of the thing. So you get cosine theta times, what's the reciprocal of 1 over cosine of theta? It's cosine theta over 1, right? Minus this one again. Agree with that? Okay. And what's cosine theta over 1? Cosine theta over 1 is cosine theta. Something divided by 1 is itself, right? So this whole thing is cosine theta times another cosine theta. What's cosine theta times itself? Is the square of cosine minus this one. This one, right? They are the same. Okay. And then let's go back to one of the main Pythagorean identity. Remember the Pythagorean identity? It's cosine squared something, let's say theta, plus sine squared the same thing. So theta is equal to 1. Remember this one? It's the main it's the Pythagorean identity. It's mentioned at the beginning of this section. Okay, so what does it mean? What's cosine squared theta minus 1? What's cosine squared minus 1? Is negative sine squared. Am I correct? So that's the same thing as saying that cosine squared theta minus 1 is equal to minus sine squared theta. Correct? So this is what I'm going to be needing over here to rewrite this whole thing as minus sine squared of theta. Make sense? So this fraction that we were given is minus sine squared theta. Whatever theta you choose, you plug it in here everywhere, as long as, I mean, this is not zero anyway, right? Secant of theta is never zero. But you need secant to make sense, so you need cosine not to be zero. Anyway, so as long as you give me a theta that makes this quotient meaningful, it's going to be the same as plugging theta in this expression. They're going to produce the same output. It's an identity, right? No matter what theta is, as long as both sides exist, they are the same. All right, moving on. So this was problem, what, 32? As promised, let's do 34. So what's 34? It's sine x times sec squared minus sine x divided by sine sec plus sine. So it's sine sec squared, again it's the same argument, it's x throughout, minus sine of x divided by sine of x secant of x plus sine of x. Correct? Okay. And I would like to simplify this. Oops, I missed a C here. Okay. Again, please pause the video and think about it. The way I'm gonna proceed is I'm gonna factor out the sign upstairs and downstairs. See if this is gonna lead us anywhere. So I'm gonna factor out sign upstairs and sign downstairs. If you factor out sign upstairs, you get sec squared of x minus 1, right? To check the work, distribute back this multiplication over the subtraction. Sine x times sec squared is sine x times sec squared minus sine x times 1 is sine x. So the numerators are the same. Denominator, again, sine x as a factor, and we get secant x plus 1. Correct. Again, you can recheck by distributing this multiplication over addition. Let's simplify now by this common factor upstairs and downstairs, sine. So let's simplify by sine upstairs and downstairs. And we get the quotient between secant squared x minus 1 divided by secant of x plus 1. Okay. All right. 1 is the same as 1 squared. Agree with me? 1 is the same as 1 squared. All right. How about we remind ourselves of the following. What's the difference between two squares, a and b? So a squared minus b squared. What is that? This is one of the remarkable identities that you learned in probably college algebra or before. This is the product between a plus b and a minus b, right? Correct? If you don't remember it, just FOIL this out, FOIL this side out, and then you should get a squared minus b squared again. And now I'm gonna invoke this property upstairs, because upstairs looks like the difference of two squares. One more time, upstairs, the structure. Remember it, I'm talking about the structure of the guy upstairs, the algebraic structure. It's the difference between two squares. And I know a result to this end. The difference of two squares is simply the product between their sum and their difference, right? With the respective order. So I'm gonna apply this. So apply this with the a being secant of x and the b being 1, right? So as such, I can see this as a squared minus b squared upstairs. So let's factor it. So what this property tells me, it's the product, right, between a plus b, so secant of x plus 1, and the difference between a and b, so secant of x minus 1. Correct? This is the guy upstairs. And the guy downstairs remains sec x plus 1. Correct? So this whole thing downstairs is one factor. And this is the same factor that exists already upstairs. So this is of the form y times t divided by y. So this is of the form y times t, this whole package is my t divided by the same y. Yt over y is simply t, right? You can simplify by this common y. So we can simplify by this common y here. How about we choose a different color? Simplify by this guy and this guy, the same package. And we're left only with secant x minus 1, right? And it has no quotients here, so we're done. This is 34. Okay. 36. Tangent squared plus 2 tangent plus 1 divided by sine tan plus sine. Again, I'm talking about the same argument throughout. So tan squared of x plus twice tan x plus 1 divided by sine of x tan of x plus sine of x, correct? Okay. The structure upstairs looks like a squared plus 2ab plus b. Let me highlight it for you. So upstairs looks like a squared plus 2ab plus b squared. Okay. Why? I'll tell you why. Let me first recall this. Actually, how about I'll tell you now. Think about a as tangent. If you take a to be tangent, so if you take a to be tangent of x, what do you think b should be to see that structure? 1, b1, then a squared becomes tangent squared of x, and b squared becomes 1 squared, so 1, and 2ab becomes 2 times tangent times 1, so 2 times tangent, so it becomes this, right? So the structure here is the same as this, if you realize that a is this much and b is that much, right? Okay. And we know a result to this. We know how to factor this guy, right? I think we did it above. Let me check again. We did, it's That's cousin in some sense. You see this? A squared minus 2ab plus b squared is a minus b squared, right? We use it a couple of times. Correct? But I'm talking about plus, which means rename minus b to be b, and as such this minus b becomes plus b. So at the end of the day you're gonna get, again, these are college algebra results. So at the end of the day this is equal to a, the sum of, or the square of this sum, right? So if you don't trust me, multiply a plus b by itself a couple of times. So a plus b times a plus b, FOIL it out, you get exactly this. Okay, so my point now is I'm gonna use this with this dictionary. Correct? That's my dictionary between this structure and this structure. A is tangent and b is 1. As such, what do we obtain? We obtain the quotient of a is tangent, so I'm gonna get the square of tangent of x plus b, which is 1, right? I mean, this guy is the square of a plus b, and a is tangent and b is 1, so you get the square of tangent x plus 1, exactly as I wrote upstairs, divided by sine of x times tangent plus sine of x. So I realized that there's a common factor, which is sine x. How about we factor that out? How about factoring out sine x? And if you factor out sine x, you get tangent x plus 1, right? If you distribute again this multiplication over addition, you get sine x times tangent, which is back this, plus sine x times 1, and sine x times 1 is sine x. Okay, and now look at this. You see a common factor to simplify? I have the square of this entity upstairs, and I have that entity as a factor downstairs. So I can simplify by tangent x plus 1, correct, and obtain the quotient between tangent x plus 1 divided by sine of x. Okay with that? Okay, we're not done. Why we're not done? Because as the question said, we need to give the final answer with no fractions. All right, let's split this sum. So this is the same thing as tangent x over sine of x plus 1 over sine of x. Right? If you want to go back, they have a common ground, common denominator. You can glue the two, right? It becomes tangent x plus 1 upstairs divided by sine x. So these are the same. Why did I write it this way? What's the added benefit? Well, 1 over sine, I know how to write it without the fraction. 1 over sine is simply what? It's cosec, right? This is this guy. And this guy, that's the same as the quotient between sine x over cosine x. What is that? This is tangent upstairs divided by sine, right? Downstairs. So this guy here is tangent, sine over cosine, and downstairs I kept it. Okay. All right. I still have to divide this part. How about isolating it and talking about it by itself? So how about doing this? Sine x divided by cosine x. The whole thing is over sine x. This is what I have, right? This is what I have. Okay. And that's the same as sine of x over cosine of x. This is the numerator divided by the denominator. Correct? And dividing by sine amounts to multiplying by 1 over sine. Yes? And as such, you realize that you get upstairs sine of x times 1, so sine of x, and downstairs you get cosine of x times sine of x, yes? Agree with me? And sine of x divided by sine of x, this is a product here, so I can simplify, and if you simplify, what do you get at the end? You get 1 over cosine, right? You get 1 over cosine of x. So all this fraction is 1 over cosine of x. And what's 1 over cosine of x? What's 1 over cosine of x? It's secant of x. Agree with that? So this is my little explanation here. That's gonna go right there for this equality. And so this whole thing is just explained in brown, I think, the color. This is secant of x plus what I had before, the cosecant of x. So this guy and the given expression is complicated looking. This is a simplified version, but they are the same as long as both of them exist. Okay, and this is, it doesn't have any fractions. Okay. All right, so 36 done. Moving on to the next objective, still on page 576. We're gonna verify identities. So previously we were trying to simplify. For example, in 36, we showed that this guy is equal to this guy, right? This is what we showed. Now they're gonna tell us, verify that this guy is equal to this guy. In other words, transition from this expression to this expression. So we're gonna try to find a way to connect the two, right? We're gonna try to find a way to connect the two, this ending point and the starting point. And we have to link them all the way by a sequence of equalities. Okay, and from every step to the next, you're gonna rely on some identity that you know holds in order to connect the two. Okay, all right, let's choose a problem. Let's do 38. So this is still on the same page number 38. Sine of negative x plus cotangent of negative x times cosine of negative x is equal to negative cosecant of x. Okay, let's zoom in a little bit. So this was number 38, as we said. Sine of negative x plus cotangent of negative x times cosine of negative x. I want to show that this is equal to, I want to verify that these two guys are the same, the two sides are the same. This is what I want, right? Okay. So should we start from the left-hand side to proceed, or to simplify it and get to the right-hand side, or should we start from the right-hand side to get to the left-hand side? We should start somewhere and connect that side to the other, right? So we need to verify this. Which side should we start from? If you think about it, you need an expression that you have enough ingredient to work with, right? This is already, it's a too simplified expression. It's already simplified. I mean, I don't have enough ingredients to work with, as opposed to here, right? I have ingredients that I can see what they mean and kind of start simplifying things, right? So I'm gonna start from the left-hand side and try to show you that this is actually the same as negative cosec of x. Okay. So left hand side, LHS. Sine of negative x. What do you know about sine? Remember the even odd properties? Very top, even odd properties. Here we are. Sine of negative x is negative sine x. Sine is an odd function, right? And in problem 38, we also have cotangent of negative x. Cotangent of negative x, even though I didn't write it here, but cotangent is cosine over sine, right? So it's cosine of negative x divided by sine of negative x. And cosine of negative x is cosine of x. And sine of negative x is minus sine of x. So cotangent of negative x is the same as negative cotangent of x, right? Let's write it down anyway. So cotangent, since we need it, cotangent of negative x. One more time, cotangent of negative x is cosine of negative x divided by sine of negative x. We've done this in class. And cosine of negative x is cosine of x divided by negative sine of x, because sine of negative x is minus sine x. So it becomes cosine over negative sine, which means the negative, the quotient cosine over sine, and cosine over sine is cotangent. So that's going to be minus cotangent of x. Okay. You can reconstruct it, but it's in your notes from the class. Okay. All right. Oh, and the last one is cosine of negative x. I still want this, but we've visited this. This is cosine of x, right? Cosine is an even function. Remember, so we have 6 trig functions: sine, cosine, tangent, cotangent, sec, cosec. 4 of them are odd and 2 of them are even. The only even ones are cosine and secant, right? In other words, the reciprocal of cosine. All the others are odd. All right. So sine negative x, as we said, is negative sine x, because sine is odd. Cotangent of negative x, we just talked about this. This is negative cotangent of x times cosine of negative x is cosine of x. Yes? Okay. And this is equal to negative sine x minus cotangent, and cotangent is cosine divided by sine, times cosine of x, right? The only thing I did here is I rewrote cotangent as cosine over sine times this part. Okay, and that's the same as minus sine of x minus, you can think about cosine as cosine over 1. So this becomes cosine of x times cosine of x divided by sine of x times 1. So we get cosine of x times cosine of x upstairs, so cosine squared, divided by sine x times 1, so sine x. Yes? Okay. How about now writing the same denominator between the two? Why I'm trying to glue them? I'm trying to collapse them to one term, because look at the nature of the right-hand side. The nature of the right-hand side is one term. So I want to condense the two, right? And how do you condense these two? One way to do it, is just to find a common denominator. That's the only way I know, right? Find a common denominator. So what's that common denominator? Is sine of x, right? So I want to write the side as something over sine of x. The question is, what is the thing? And here it's already over sine of x, so I'm just going to copy it. Agree? So what is this guy? Well, I used to have over 1, right? I used to have this over 1. So what did I multiply this 1 downstairs to get sine? I multiplied by sine. So I want to also do it upstairs in order to preserve the value of that expression. And if you multiply this upstairs by sine, you get negative sine squared. check it back. If you simplify this expression, this is negative something squared divided by itself, right? By, not itself, negative a squared divided by a. Negative a squared divided by a is negative a, right? So we're back to this. Okay, now that we have the same denominator, let's glue them together. Let's build this bridge, and what do we get? We get, downstairs is obviously this common thing, minus sine squared of x minus cosine squared of x. Agree with me? Okay, almost there. Keep an eye on what you want. You want cosec of x. Okay, cosec is 1 over sine, right? So this looks like negative 1 over sine then. Negative 1 over sine. It looks like upstairs is going to be negative 1 then. It looks like this whole thing upstairs is negative 1. Why do you think this upstairs guy is negative 1? Well, factor out negative 1. Let's see what happens. If you factor negative 1, you get sine squared of x plus cosine squared of x divided by sine of x, right? Agree with me? Negative 1 times the sum is going to be negative 1 times the first, so negative sine squared, plus negative 1 times cosine squared, so negative the cosine squared. So you get back this numerator. This is correct. But this makes the property that I'm about to use more pronounced. And what's this property? It's the Pythagorean identity. Sine squared of x plus cosine squared of the same x is 1. So this whole thing is 1 then. So this whole thing is 1. It's the Pythagorean identity. So this whole thing then, as we expected, right? This whole thing then is equal to minus 1 over sine x, which is equal to minus the 1 over sine x, which is cosecant of x, as wanted to show. Right? Just to be very clear, this is the right hand side. This is the right hand side. Agree? This is the right hand side. It's right there, as wanted to show. Agree with that? So let's keep going. So this was 38. All right, let's do one of these, 41 through 46. How about 46? These are almost the same. So let's do 46. Okay, so I have to show, I need to verify that this equation is an identity, which means both sides are the same all the time, as long as both of them exist. So 1 over 1 minus cosec of x minus 1 over 1 plus cosec of x is equal to negative 2 tangent x times secant of x. Okay, so we're talking about 46. And 46 is 1 over 1 minus cosecant of x minus 1 over 1 plus cosecant of x. And we want to verify that this is actually negative 2 tangent of x secant of x. Okay. So this is what we want to show. Okay, so which side are we going to start with? I mean, you can start here and see how far you can go, and kind of start back from here and kind of glue the two ways, right? My point is, this is what I was saying. So you have left hand side. And you want to write a sequence of equalities, right? So equalities, and eventually you're gonna get the right hand side, correct? This right hand side. So my point is, start from the right hand side if you want and go up as much as you can. Somewhere maybe you're gonna be blocked, right? And then start from the left hand side and go down. Hopefully um, you see this intermediate stage between the left hand side and the right hand side, right? So this was my point. So start from his side. If you're not sure where to start from, I mean, if both of them are complicated looking, in this case it's probably better to start from the left hand side because you have more tools to work with, more ingredients I should say. But if you decide to go from the right hand side, and let's say you keep going, but at some point you're gonna be blocked. But I mean, by blocked I mean you don't know how to proceed after that. So you don't see the left hand side if you start from the right hand side. My point is, don't panic, just stop here and then start from left hand side and proceed. Hopefully you get to this stage, which is an equivalent, which is the same expression as the right hand side, because you said they're all equal, right? So that's what I was saying. Okay. So this is the strategy in some sense. Let me erase everything in here. Okay. All right. Let's start from the left-hand side in this case. Again, you do whatever you want as long as you show that they are the same. How about finding a common denominator between the two? How about finding a common denominator between the two? How about the product between those two denominators? So I have these two quotients. I'm going to keep them. And I'm going to write each one of them as the product of the two, right? This would be my common denominator for both of them. Okay. So this would be my common denominator for both of them. I want to adjust the numerators, obviously, to keep the value of each quotient. Well, what did we do from this 1 minus cosine x to the product? We multiplied downstairs by 1 plus cosecant of x. We're going to multiply, since we multiplied downstairs by 1 plus cosecant of x, we could also do it upstairs to preserve the value of the quotient. So we get 1 plus cosecant of x upstairs. Oops. Upstairs, right? And similarly, on the left, for the left expression, for the right expression, we multiplied downstairs by 1 minus cosine of cosecant of x, right? We had this guy, 1 plus cosecant. We multiplied by 1 minus cosecant downstairs to create this common denominator. And so we got to do it also upstairs. So 1 minus cosecant of x. Yes? Okay. And let me ask you the following. What does this look like? This looks like a minus b times a plus b, right? This looks like a minus b times a plus b. I'm talking about the denominator, that common denominator that we just created. One more time, it looks like 1 is a, and this guy cosecant of x is b. This becomes a minus b times a plus b. And do you know anything about this? We just discussed it above. Hopefully I can find it for you. Where did we do it? It's right there. It's the difference of two squares, right? So a minus b times a plus b, I'm using it right to left this time. A minus b times a plus b is the difference of the squares in the respective order. So I'm going to get a squared minus b squared, right? Who's the a, who's the b? 1 is a, cosecant of x is the b. So this is what's going on downstairs. That's the structure of the guy downstairs. So that common denominator as we said, is a squared minus b squared, and a is 1, so it's 1 squared. Let me just write it in gray just to highlight it. So 1 squared, which is 1, minus b squared, which is cosecant squared, right? And upstairs, what do I have? I have this numerator minus this numerator. So we get 1 plus cosecant of x, the numerator of the first expression, the left one, minus, see the minus? Minus the numerator, the entire, this minus is for the entire numerator, right, of the second expression. So 1 minus cosecant of x. Agree with me? Okay. So that's the same thing as downstairs. We agreed it's 1 minus cosecant square of x. And upstairs, I'm going to have 1 plus cosecant of x minus 1 plus cosecant of x. How do we get the plus? Well, I destroyed the parentheses here. You have minus a package. If you want to drop the parentheses, everybody inside is going to flip sign. So the 1 is going to become -1, and the minus cosecant is going to become plus cosecant, right? Okay. And 1 minus 1 is 0. Right. And cosecant plus itself is twice cosecant. So upstairs is twice cosecant. And downstairs is 1 minus cosecant square of x. Okay. Let's take a look at our desired right-hand side. So our desired right-hand side is this. Correct? It's -2 tangent x secant of x. We got the 2. We still have the minus and tangent and secant. Correct? This is what we still have. Let me revisit something I mentioned at the beginning of this section. It's right there. This one. 1 plus cotangent squared is cosecant squared. Keep in mind, 1 plus cotangent squared is cosecant squared. It's one of the Pythagorean identities. Let's invoke this thing here. So we know that 1 plus cotangent squared of x is equal to cosecant squared of x. Let's subtract by cosecant squared plus cotangent squared. So we get 1 minus cosecant squared of x is equal to negative cotangent square of x. They're the same thing, right? I moved this guy to this right side, left side, and I moved cotangent squared to the left side, to the right side, and we get this. So how about we employ it here for the denominator? Let's see how it's going to unfold. That's going to be, downstairs is going to be negative cotangent squared of x, and 2 cosecant of x upstairs still. Correct? So we got our minus. Remember, in the desired answer or desired right hand side there is a minus. We got it. It looks like those guys, cosecant and cotangent, we have to transition to secant and tangent, right? So somehow we're gonna get secant and tangent. Let's rewrite what each one means. So this is the same as -2 times cosecant of x over cotangent squared. I just pushed out the -2 because this is something I want to preserve, right? I mean, it's part of the conclusion. And somehow this quotient is going to be 10x times secant. Let's convince ourselves. So we get that's equal to -2 times cosecant is 1 over sine, am I correct? The reciprocal of sine is cosecant. And cotangent squared is cosine squared x divided by sine squared x, right? Cotangent is cosine over sine, so the square of cotangent becomes the square of this quotient, which means cosine squared over sine squared. Okay, let me move here. This is -2 times this quotient, and this quotient means 1 over sine x divided by cosine squared of x over sine squared of x. Correct? Okay. And dividing by cosine squared over sine squared is the same as multiplying by sine squared over cosine squared. So that's going to be equal to -2 times 1 over sine x times sine squared of x divided by cosine squared of x. Okay. And as you see here, sine squared divided by sine, I'm going to be left with 1 sine upstairs. So dividing by sine of x cancels one of the sine. I have 2 sines upstairs, right? Sine x times sine x is sine squared x. So one of them is going to cancel with sine. This is going to become a 1. And upstairs is going to become sine x. So this becomes, at the end, -2 times sine of x over cosine squared of x. Okay, I agree, this is not what we want. What did we want? We wanted -2 tangent times secant. We wanted -2 tangent times secant. Well, let me show you what I meant before I started this problem. Let's pretend you don't see. I mean, I'm sure some of you do see the conclusion. Let's pretend we don't see it. So how about we start with it, let's say here. So -2, the right-hand side above is -2 tangent times secant of x, right? So somehow I want to connect this piece to this piece. Well, the -2 is already connected. Somehow that's going to be connected to this, right? If you don't see it, let's go back. Let's go back. So tangent is, I'm going back, right? I'm trying to connect. I'm trying to see the connection. Sine, tangent is sine over cosine, right? And secant is 1 over cosine. Am I correct? Secant is 1 over cosine. This guy is 1 over cosine. All right, but now look. Sine x over cosine x times, this is a multiplication here, times, let me fix it, so times 1 over cosine x, it's a product of 2 quotients. How do you multiply 2 quotients? Straight across. So you get the quotient of the product of the numerator divided by the product of the denominator. Sine x times 1 is sine x, cosine x times cosine x is cosine squared. So there it is. This is the connection. This is a convincing step then, right? And this expression is the final result, and hence we're done. Correct? So let me take this for you over here. Oops. And just drag it a little more. This one too. Okay. and that's the right hand side that we want. So that's the right hand side that we want. Correct? So long story short, oops. So long story short, the left hand side that we started with, which is this guy, we found a sequence of equalities. Each one is built on a concrete identity. I mean, something that's logically correct, an identity. And then somehow we connected the two ends and we got to the desired right-hand side. Okay. So this was 46. Right. Let's go to a problem from 47 to 52. How about 52? Let's go for 52. Sine x plus cosine x divided by sine x minus cosine x. And so somehow we want to manage to show that this is the quotient between 1 plus 2 sine x cosine x and 1 minus 2 cosine x squared. So that's 52. So we want to show that sine x plus cosine x divided by sine x minus cosine x is equal to 1 plus 2 sine x cosine x over 1 minus 2 cosine x squared. Okay. And this is what we want to show, right? All right. Again, I'll pause the video and try to do it. The way I'm gonna proceed is I'm gonna multiply the denominator by sine x plus cosine x. Why? Because I sensed the numerator here that this looks like a squared plus 2ab somehow. Or something plus 2ab. So somehow I'm gonna need probably the square of sine x plus cosine x. Correct? I mean, this is the observation I made. Okay, so let's create this square of sine x plus cosine x by multiplying and dividing by sine x plus cosine x. I hope you find a different way to do it. So I'm gonna start with what I have. That's my current left-hand side. And what I want to do, I want to multiply it by 1, right? But this one, the format of this one is going to be sine x plus cosine x divided by sine x plus cosine x. This is a 1, right? No doubt. Agree with this? That's a 1, no doubt. But this is gonna help me create this 2 times AB. Okay, you're gonna see. All right, so this upstairs becomes sine x plus cosine x squared, and downstairs becomes sine x minus cosine x times sine x plus cosine x. That's downstairs. Okay. All right, regarding downstairs, this is of the form, regarding downstairs, this is of the form t minus z, let's say, times t plus z, right? The guy downstairs I'm talking about. This is of the form t minus z times the same t plus the same z. And it should look familiar by now. I mean, we've done it a couple of times above. This is t squared minus z squared, right? Correct? So that's gonna tell me that downstairs may be written as, I'm talking about downstairs, may be written as t squared, so who's t? Sine x, and z is cosine x. So t squared, so sine squared of x, minus cosine squared of x. Correct? And upstairs, let's use a different color for this. Upstairs, it looks like the square of his sum, right? Upstairs, I'm talking about sine x plus cosine x squared. This looks like a plus b squared, the square of his sum. Okay, and also we've done it above. This is a squared, or we talked about it above, plus 2ab. That's the term I wanted to see from the get-go, right? Because look, this 2ab, if a is going to be sine x and b is going to be cosine x. Do you see this? 2ab, it's right there. So that's why this is what was inviting to kind of like have a square of sine x plus cosine x upstairs, right? Okay, plus b squared. Okay, so I'm going to use this for the numerator. And as we said, sine x is going to be the a, and cosine x is going to be the b. So it's going to be sine squared x, that's the a squared part, plus 2ab, so plus 2 sine cosine, right? Which would be part of the conclusion, right? You see it? Plus the square of b, right? And b is cosine, so it's going to be the square of cosine. Yes? All right. And take a look. What did we want? We wanted, let's focus upstairs first. 1 plus 2 sine x cosine x. So you see this term? Let me highlight it for you. So this term that you see here, it's already in the conclusion. So this looks good to me, correct? So somehow the other two parts are going to be 1. So somehow that's going to be 1. Is it correct? Sine squared x plus cosine squared, is it 1? Yes, right? So sine squared x plus cosine squared x is 1. This is the Pythagorean identity. Okay. So we get then so by the Pythagorean identity, sine squared of x plus cosine squared of x is 1, right? So what I'm talking about is I can simply just keep this guy and add the other two parts. Sine squared plus cosine squared is going to be 1 plus this highlighted thing, 2 sine x cosine x. So that looks good upstairs. So we got our hands on the guy upstairs, right? So we're done with upstairs. Now for downstairs, let me erase these. For downstairs, I'm gonna have 1 minus 2 cosine squared. I have one of the cosine squared. It's right there, the minus. So somehow I'm gonna pick up another one from this and pile them up to get a minus 2 of this copy. And somehow I'm gonna also pick up a 1. So this guy apparently is gonna produce 1 and another cosine squared. So one more time. Downstairs I should get 1 minus 2 cosine squared. So I have, this means 2 copies of cosine squared. I have one of them, negative cosine squared. I have one of them. So which means this left guy is gonna come with a 1 and another cosine squared, minus cosine squared. Do you see why? It's already here, right? Can you solve for sine squared? Solving for sine squared is going to give us sine squared x equals 1 minus cosine squared, right? Agree with me? So this one is, the darker one is downstairs I'm using. This lighter one upstairs I used. Sine squared x can be rewritten as 1 minus cosine squared. So let's take this guy and write it as 1 minus cosine squared. And what do we get? We get 1 minus cosine squared. This is this guy. Okay, let me put it between parentheses. Minus the existing 1 cosine squared, which already existed before, right? This highlighted one. Okay. All right. So that becomes the desired conclusion, right? Because minus cosine squared x minus cosine squared x is the minus 2 cosine squared, and then that's the right hand side. And we're done. So is 1 plus 2 sine x cosine x divided by 1 minus 2 cosine squared x, which is exactly, as discussed, the right hand side, right? Okay. All right, so this is 52. All right, let's move on to the next group. How about one of these? How about 56? So you have ln, or you want to show ln of the absolute value of cosecant of theta plus cotangent of theta is equal to minus ln of cosecant of theta minus cotangent of theta. So this is 56. So we want to show that ln, the natural log of cosecant of theta plus cotangent of theta, an absolute value, is equal, that's what we want to show, negative ln of cosecant of theta minus cotangent of theta. Okay. All right. It looks like no matter where we start, they're almost the same. So, all right, you choose your side and start from there. Let's see. Well, let's say left hand side. So I have ln of the absolute value of cosecant of theta plus cotangent of theta, right? I want to introduce this desired thing. Somehow I want to introduce this cosecant of theta minus cotangent of theta. How about we multiply and divide by this thing? See what happens. So how about we multiply and divide by the same thing? It's a 1, right? So I'm gonna multiply, remove this, multiply and divide by the same thing. And that thing, I'm going to choose it to be cosecant of theta minus cotangent of theta. So that remains a 1, right? Why? Because the conclusion suggests that. So the conclusion suggests that this is going to be involved in the game. All right. Well, what do we get? We get ln of the absolute value of, upstairs we have cosecant theta plus cotangent theta times cosecant theta minus cotangent theta, and downstairs cosecant theta minus cotangent theta, right? Okay. How does this, what's the structure of the expression upstairs? What's the structure of the expression upstairs? Isn't it t minus z times t plus z, which is this, which is that, t squared minus z squared? So take a look. Doesn't look like t plus z times t minus that z, right? The structure is the same, so I'm gonna use that. So let me highlight it for you again. So what we're using is t plus z times t minus z. That's t squared minus z squared, right? That's what we're using here. And the t is cosecant of theta and the z is cotangent of theta. So that guy upstairs becomes one more time. So the guy upstairs becomes cosecant squared of theta minus cotangent squared of theta. And downstairs we get cosecant theta minus cotangent theta. Correct? And what do we know about this one? What do we know about, it's one of the Pythagorean identities we talked about above. What do you know about 1 plus cotangent square of theta? If you revisit that identity, or you can reconstruct it, this is cosecant squared, right? This is cosecant squared. Agree with me? So what can you say then about cotangent squared minus cosecant squared? So I meant cosecant squared minus cotangent squared, which is this. If you subtract both sides by cotangent squared, you get 1 here and you get exactly the numerator on the right side, right? So that's 1 then. So that's 1. Since this holds, right? Makes sense? So one more time. What did I do here? Since this is holding for me, I can use it. And then what I'm going to do is I'm going to subtract cotangent squared both sides. If you subtract cotangent squared here, you get 1. If you subtract cotangent squared here, you get the numerator, cosecant squared minus cotangent squared. So this side is 1 is equal to the numerator, so that these two are the same. Okay. And this means that this is equal to ln of the absolute value of 1 over cosecant of theta minus cotangent of theta, right? And the absolute value of a quotient is the quotient of the absolute values. So this becomes absolute value of 1 divided by absolute value of cosecant theta minus cotangent theta. And absolute value of 1 is 1. So we get, one more time, absolute value of a quotient is the absolute value of the quotient. So we get absolute value of 1 divided by the absolute value of cosecant theta minus cotangent theta. But what's absolute value of 1? It's 1, right? So let's erase these things. So we get this. Okay. Closer. This looks closer to the what is it? The right-hand side, which is the way we're headed, right? But I wanted it to be upstairs as opposed to downstairs, and I wanted a minus to be there. Well, how about we remind ourselves? What's ln of a minus what's ln of a divided by b? This is ln of a minus ln of b, right? Remember this property from college algebra or an earlier class? Okay. And so what can you say about ln of 1 over b? Just replace a by 1, you get ln of 1 minus ln of b, right? Correct? And what's ln of 1 one more time? ln of 1 is 0, correct? Again, I'm using properties you learned in previous courses. So this guy is equal to minus ln of b, right? So what? Look here at, it's highlighted. Look at this guy and look at this guy, right? What can you say? Oops. What can we say here? ln of 1 over b is equal to minus ln of b. Well, this is what we had, right? ln of 1 over b is equal to minus ln of b. So this whole thing is going to be what? Minus ln of the absolute value of cosecant theta minus cotangent of theta, right? So this equality on this previous page is minus ln of b, and b happens to be cosecant of theta minus cotangent of theta. Let me just drag it to the side a little more. Minus cotangent of theta, right? And what did I use here? We used the writing in green. So this last step to connect this side, this expression with this expression, I appeal to a property that I learned in a previous course, college algebra, let's say, to rewrite ln of 1 over b as negative ln of b. And that's the right hand side, right? That's the right hand side. So we're done. That shows 56. The equation, the identity of 56. Okay. Let's move on. And let's go back to the book. Let's choose one of the problems from 61 to 68. And let's say 66. Okay. The question is, write the given algebraic expression as a function of theta. So you have an algebraic expression in x. You want to rewrite it in theta, and they gave you a substitution. Just replace x by this much, where theta is assumed to be between 0 and pi over 2. So it's an acute angle. Okay. So we want to rewrite square root of x2 plus 16 divided by x with this substitution as a function of theta, and they told us that theta is an acute angle, right? So that's number 66, as we said. So we've given this algebraic expression, and we want to substitute x by 4 tan theta, right? Okay. So this expression, how about we call it E for expression? This expression is the same as the square root of the square of x, which is 4 tan theta, plus 16 divided by 4 tan theta, right? Correct? I just replaced x by 4 tangent theta. Alright, and this is the same as the square root of 4 tan theta. This is a multiplication here, right? So that's a product. 4 times tangent theta squared is 4 times 4, so 16. And tangent theta squared, so tan square of theta plus 16, right? This 16. And the whole thing is divided by 4 tangent theta. Okay. And we need to simplify this expression as much as we can. How about we factor out 16 inside the umbrella? So we get the square root of 16 times tangent squared of theta plus 1. The whole thing is divided by 4 tangent of theta. Right? Okay. Tangent theta squared, so tan squared theta, I should say, plus 1. This entity, what do we know about this entity? Tangent squared theta plus 1. What do we know about this? It's one of the what is it? One of the Pythagorean identities, right? At the beginning of the section. It's right there. You see it? Tan squared theta plus 1 is secant squared theta. Okay? So this is secant squared theta. So let's invoke that in the numerator. And we get that this is the square root of 16 secant squared theta divided by 4 tan theta. Yes? Okay. Well, square root of a product is the product of the square roots. So you get square root of 16 times square root of secant squared theta divided by 4 tan theta downstairs. Yes? Okay. Square root of 16 is 4. And square root of secant squared is the absolute value of secant, right? Remember, square root of something squared is the absolute value of the thing, because that thing may be negative, right? Divided by 4 tan theta. But here we were given that theta is an acute angle, right? So we were given that theta is an acute angle. So we were given that theta is between 0 and pi over 2, so it's acute. As such, what do you know about the secant? Secant theta must be positive, right? Remember, secant is 1 over sine, 1 over cosine. And cosine in the first quadrant, because theta is between 0 and pi over 2, so it's the first quadrant. Cosine the first quadrant is positive, so this becomes 1 divided by a positive number, which means positive, right? Okay, and then the absolute value of that thing, the secant, if the secant is positive, the absolute value of secant is secant, right? Because the absolute value of a non-negative number is that number. So we get upstairs 4 secant divided by 4 tangent, right? So this guy is secant, as we just said, because the absolute value of a positive number is that number. And the 4 and the 4, I'm going to cancel them. So I'm going to cancel them. And then I get secant theta divided by tangent theta, right? Okay. We can still do some simplifications here. Tangent is sine over cosine, and secant is 1 over cosine, right? Agree with me? Okay. Okay. So that's the same as 1 over cosine. I'm playing the same game that we did before. I mean, we've done it probably 2 to 3 times. Let's do it one more time. And we get this, right? I mean, this is what this means. It's the numerator divided by the denominator, right? And as such, you get 1 over cosine of theta times the reciprocal of that guy that sits on the right, the right side, you get cosine theta over sine theta. And I hope you see the simplification part. Cosine theta and cosine theta cancel each other, and you get 1 over sine. And 1 over sine is simply cosecant of that argument, which is theta. Okay. All right. So we're done with 66. I mean, the rest are very similar. How about, let's do one of these 4 guys. How about this one, 72. So the question is factor the expression and simplify factors using fundamental identities if possible. So 1 minus cotangent to power 4 of theta of x. So number 72. We have 1 minus cotangent to power 4 of x. Okay. Oops. Okay, so that's equal to this looks to me the difference of two squares. Let me write it so you see it. This is of the form 1 squared. 1 squared is 1, right? Minus the square of cotangent squared. Do you agree with me? Do you agree with this? So what did I use here? I merely used the fact that a to power 4 is equal to a squared squared. That's what I used. Right? That's what I used. And my a happens to be cotangent of x. So this cotangent to power 4 is the same as the square of cotangent squared. Right? So we get that. And now this is of the form a squared minus b squared. So this is of the form a squared minus b squared. And what's a squared minus b squared? It's a minus b times a plus b. We've done this a few times above, right? So I'm using it here. And who's the choice of a? A is 1. That's the a. And who's the b? Is cotangent squared of x, right? So this becomes a squared. So a is 1 minus the b is cotangent squared of x squared. So b squared. So the b is cotangent squared. I don't know if I should, let me write it here. So where or with a being 1 and b being cotangent squared of x, right? So I'm giving you directions here. Use this with these choices. Okay. And as such, we get, so it's a minus b times a plus b, and a is 1, b is cotangent squared. So just write that. So it's 1 minus cotangent squared of x times 1 plus cotangent squared of x, right? On one hand, what is this guy? Revisit one of the Pythagorean identities above. 1 plus cotangent squared is cosecant squared. Right? And on the other hand, I can re-employ this property, the difference of two squares, right there. I can see this 1 as 1 squared, right? I can see 1 as 1 squared. Let me write it in gray. And as such, you can see this factor as a squared minus b squared. Am I correct? So you can reuse this now with the choice a to be 1 and b to be just cotangent. Make sense? So you can re-employ this previous thing. So what we're gonna do here is we're gonna use a squared minus b squared equals a minus b times a plus b another time, but this time around is with a being 1 and b being cotangent of x, right? So that's what we're using. Okay, and as such we get a minus b times a plus b times the brown thing, which is cosecant squared. This whole thing is cosecant squared here. Correct? All right, so we factored it as, we responded to the question because we needed to factor the expression and simplify the factors using the identities, remarkable identities. So such a thing here, and that identity here as well, right? One of the Pythagorean identities. Okay, so that was 72. Okay, moving on to the next chunk of problems. These are problems that kind of like combine things we've done, so let's do a few. Let's do one from this set here. How about AD1? Let's do AD1. Oh, AD1 is an odd one, so let me choose the even as promised before. Okay, let's do number 80. Okay, so I want to show, right? I want to verify that the equation is an identity, so I want to show that this side is equal to that side for all x. Okay, so left side is 2 tangent to power 4 plus 7 tangent squared plus 5 divided by secant squared, and this is equal to 2 tangent squared x plus 5. So this is number 80. Okay, so number 80. So I have 2 tangent power 4x plus 7 tangent squared x plus 5 divided by secant squared of x is equal to 2 tangent squared of x plus 5. This is what we want to show, right? Before we start, let me recall the following. How about if you have the following situation? 2 times a squared plus 7a plus 5. If you want to factor this second degree polynomial. If you don't have the intuition into it, you can use quadratic formula for it. And what you should get is 2 times a plus 1 times a plus 5 over 2, right? Let me check quickly. Yep, you should get this. Okay, and what I want to do is I'm looking at the left hand side numerator. The structure is the same, and if you realize, I'm gonna use this with a being tangent squared, right? That's what I'm gonna do. So I'm gonna factor this numerator by using this where a is tangent squared. Let's read it. Replace a by tangent squared. This becomes the square of a becomes the square of tangent squared, which means tangent to power 4, right? X. And here it becomes tangent squared. So once you do the substitution, this guy is exactly that numerator, and you can factor it as follows. 2 times tangent squared plus 1, remember a is tangent squared, times tangent squared plus 5 over 2. That would be the numerator. Okay, so that's exactly what I'm going to do as a first step. So left-hand side. So left-hand side is equal to this other way to write the numerator. So I'm rewriting it. So I'm using, this is my package to transition from the stage 1 to the next one. Okay. Oops. So 2 times a, which is tangent squared, plus 1, right, times a, which is tangent squared, plus 5 over 2. Agree with me? Okay. Divided by secant squared of x. Oops, I forgot to write the x altogether here. Okay. All right. And what do we know about, tangent squared plus 1? Tangent squared of x plus 1. This is one of the Pythagorean identities. This is exactly secant squared theta, right? So let's use this because I see tangent squared x plus 1. Oh, I meant secant squared x, obviously, here, not theta. Right, because I used x here. So this is equal then this is equal then 2 times this guy tangent squared plus 1 is secant squared, so this is secant squared of x times tangent squared of x plus 5 over 2, right? Okay. Divided by secant squared x. Keep an eye on the right hand side, what you wanted. Okay. This factor secant squared can be found downstairs. It's the same one. So I can simplify by secant squared. And then we get 2 times, downstairs is 1 now, 2 times tangent squared x plus 5 over 2. And if you take a look at the right hand side, the desired entity that I want to get to is exactly this, right? Just distribute now the multiplication over addition, you get exactly what you wanted. So that's exactly the right hand side. Why? Because, I mean, just multiply 2 with this tangent squared is 2 tangent squared, and multiply 2 with 5 over 2. 5 over 2 times 2 is 5, right? And that's exactly the right hand side as desired. Yes? Okay. Very good. So this was number what? This was number 80. Let's keep going. Let's do 1 or 2 more. Let's do one of these two. 100 or 102. Which one should we do? Probably, I mean, let's do both of them, okay? Let's do 100. So ln of the absolute value of cotangent plus ln of the absolute value of secant plus ln of the absolute value of sine is equal to 0. This is 100. So I have ln of the absolute value of cotangent of x plus absolute value ln of secant of x plus ln of the absolute value of sine of x. I want to show that this sum is just 0. Okay. Well, the left-hand side, the left-hand side is equal to, if you recall one of the properties you learned in college algebra, ln of a sum, ln of a product. How about we write it like this? ln of a plus ln of b is equal to ln of a times b, right? So ln of a product is the sum of the ln's, right? Probably this is the way you said it at the time. So I'm gonna invoke this. So I certainly have sum of ln's, so I certainly have this format. And let's condense it, writing it as ln of the product, right? ln of a plus ln of b plus ln of c. This is ln of a times b times c. So by this property, right? Right here. So this is ln of the product of these entities, the absolute value of cotangent of x times the absolute value of secant of x times the absolute value of sine of x. Well, the product of the absolute values is the absolute value of the product. So this is the absolute value of cotangent x times secant of x times sine of x, correct? And we're gonna find it to be 0, which means this guy should be 1, correct? This guy should be 1 because ln is a one-to-one function, and the only time it reaches 0 is when the input is 1. So this is technically, we're talking about 1 here. Okay, let's discover this. Okay, so this is ln of cotangent is cosine over sine, and secant is 1 over cosine, right? And I'm copying the last one, which is sine. Agree? Okay, and I hope you see that this is actually 1. Let's convince ourselves. Cosine x divided by cosine x, that's 1. And sine x upstairs and sine x downstairs, this is also 1. So the whole thing is simply 1. So this is ln of 1, which is 0, which is the desired right-hand side. Okay, so this shows the validity of this identity. Okay, as I promised you, let's do 102. I want to show that log, remember log means log base 10, right? And ln means log base e, the Euler number e. So here, log base 10 of 100 sine x is equal to 2 sine x. Okay. So this is 102. We want to show that log base 10 of 100 Remember, this is a notation, log base 10. You don't write the base, correct? It's the common logarithmic function. You want to show that this is twice sine x. Okay. Well, let's start. Left-hand side is equal to this guy, but I wanna use one of the properties of logs. Log, what do you know about log of a to power alpha? The alpha, the exponent, goes to the level of the coefficient, and you get alpha times log base a. Let's keep the base 10, log a, right? So I'm gonna use this with a being 100 and alpha being sine. So I'm gonna use this with a being 100, right? The a is 100 and the alpha is sine of x. And this becomes sine of x times log of 100, correct? And 100 is the same as 10 squared. Agree with me? Okay. And what's this guy? This is a 2, right? This is a 2 since log base 10 is equal to 1 and log base 10 of 10 squared is equal to 2 log base 10 of 10, correct? Let me make some room here. So one more time. Log base 10 of 10, log base a of a is 1. And this guy here, you can use this property that I just mentioned, where a is 10 and alpha is 2. So that becomes 2 times log base 10 of 10. And since we said log base 10 of 10 is 1, this becomes 2 times 1, so this is 2 then, correct? So this becomes sine x times 2, this whole thing is 2, just 2 sine x, which is the right hand side. Yes? Okay. All right, let's do one more. How about 106? So given that the function f of x is 1 divided by square root of x2 plus 1 and g of x is tangent of x, show that the composite function f composed with g at x is cosine of x. Okay. All right. So this is, as we said, 106. So we know that f of x is given to us as 1 over square root of x2 plus 1. And we're given also that g of x is equal to tangent of x. What we want to show, that the composite function f composed with g acting at x is nothing more than the absolute value of cosine x. That's what we want to show, right? Okay, let's do it. Remember composite function? How does the composite function operate? Well, it's f acting at g of x, right? So this is f acting at the function g of x, and what's the output of g of x? It's tangent of x. Correct? That's g of x. G of x is tangent of x. And now how does f operate? Well, if you don't like x here, let's cover this with an asterisk. Look, f of something is equal to 1 over the square root of the thing squared plus 1. One more time, how does f operate? F of an input is equal to 1 divided by the square root of the square of the input plus 1. Correct? Who's my input now? Tangent of x. That's my input. That's my input, right? That's taken the role of the asterisk that we just built here. Okay. So this is then equal to 1 over the square root of the input squared plus 1. Agree with that? Okay. What we want to show? We want to show that this is ultimately becomes the absolute value of cosine of x. Okay. What do you know about tangent squared of x plus 1? It's one of the identities, one of the Pythagorean identities. This is secant squared of x, right? Okay. So that's then equal to 1 over the square root of secant squared of x. And I hope you see it. Remember, my eye is on this, right? That's the conclusion that I want. Well, what's the square root of secant squared? Well, the square root of something squared is the absolute value of the thing. It's the absolute value of the thing. Oh, correct. And 1 is upstairs. Do you agree with me? Square root, so what I'm saying is the square root of a squared, I think we used it above one time, is the absolute value of that a. Correct? Okay. And 1 divided by the absolute value of secant is the same as the absolute value of 1 over secant theta. And what's 1 over secant? That's cosine of theta. As wanted to show, right? That's what we wanted to show. Make sense? Oh, where is it? It's right there. Okay. All right, so this is the end of the section.